Good afternoon. Welcome to the Java basic training. My name is Dennis Kishangi to try and accomplish in this class. So what we want to accomplish in this class, it's my huge belief that that all IT professionals should be able to know basically how to do the coding. So this we'll do 4 introductory classes, this being the first one. And what we'd want to do is ideally within the 4 introductory classes, cover basic coding. Then after that, then we can do more advanced classes. So we'll do a PowerPoint presentation to highlight that. So this is where we start. So today we will cover 4 topics. The first one being introduction, and in the introduction I'll cover why I think we should learn coding. On that, I'll be able to give a story that will introduce us to the next thing on computer basics. And then we look at introductory elements that you need to know on basic programming. And then I'll highlight a project that we will do. And on that, I'll do very basic coding in Java to be able to just introduce you to Java. I think if I may give my story and highlight why I'm even obligated to teach. In 1992, my father decided to ask a neighbor who was called Mr. Gavito to basically teach me some computers. That time I was in high school. The lessons I learned were very critical to a lot of things that I managed to understand in computers. I was able to learn basic elements of a computer, like that time we were using DOS. Windows 3.1 was trying to come out, but I mainly learned DOS, which meant learning computers was much easier. And one of the things I found, it was a lot of fun to be able to do and be able to use it to solve everyday basic problems. Right now, many people use the computer just that they don't feel like they use a computer, because they will do text messaging, they will do Facebook, they'll be live on web stream. So they'll do all these things. I think they'll be on a computer that they are not too familiar that they are on a computer. So that was one of the things I learned, that it is quite a bit of fun. The other thing that I learned was, when you learn some basic coding, it makes your brain start to analyze things in a way you want to have somebody else do a task. If you do something, I find, for example, footballers, the way they learn to kick the ball, they train themselves in a way that their body reacts, and it'll already learn how to be able to do the football without literally thinking. So if you tell a person to teach you how to play football or to learn how to swim, it's difficult for them to then re-engage and give you that. When you code, you basically have to break down what you think needs to be done in instructions to be able to give somebody else. And you can think of then programming in a way that if you are to instruct anybody to do something, how do you break down that language? With human interaction, it's easy to break it down. With computers, you have to really break it down. Also, when you do that, you get acquainted with computer basics. You have to learn a bit more of how the computer functions. And I have understood, when you understand that, then on intuition, it makes you know how to handle the hardware better, to handle networking better. So it doesn't matter if you're doing networks, whether you're doing maintenance, whatever you're doing, if you understand coding, then you have a much better understanding of whatever it is you're doing. And the last point is, from 1992, coding became my bread, whether it's the career I've done or business. And I can guarantee you, if you learn how to code and code like a professional, the thing you never see is you'll never go hungry. I cannot guarantee that you'll be very wealthy, but you will never go hungry. Biggest thing of learning coding I have found is the way at times it's been approached in school. It looks such a tough subject, so it makes some people not really want to engage in it. But we'll try within these classes to break down the myths, and put it to be in a way that everybody can then be able to easily understand how to code. Most important, know where to begin, be able to write very simple language. And just to throw you off slightly, I'll tell you my understanding of what a computer is. And then, because the understanding of what a computer is very critical to how you instruct it. My understanding of a computer is, the core thing is the central processing unit. And what happens with the central processing unit, all it does is handle instructions. To be able to keep the instructions, we use memory to just keep the data and the instructions. So I normally find the CPU maps to the memory, and then everything else, any input-output device, is mapped together. So even if you look at a phone, you have your output as a screen, you have the same input as a screen. In it, you have some memory, and then in it, you'd have the CPU. The computer is not very bright. It breaks down every single instructions into very, very basic code. All computers, whether it's the phone, and every instruction is done one at a time. Now, when programming was that difficult, it used to be quite hard to do any sort of coding. Nowadays, it's been broken down to a level that it's really intuitive to be able to instruct the computer. If I may take a bigger pictorial view of the CPU, that would have the control unit, which manages how the instructions are sent to memory. The register is a smaller memory that keeps the actual instructions that are almost being processed and the data. And the arithmetic and logic unit just then handles the operations that it's told. The computer is among the most dumbest of things I have studied, because it doesn't do very many things. But what it's able to do is ensure the little instructions it can handle, it can do them pretty fast. That means then it gets a very big array of what it can do. So if you are looking at assembly language, the number of instructions on an assembly level would not be very many. One of the things I will show you is how to disassemble. I'm only able to know that in Linux. You can also do that in Windows. You can disassemble any executable program and be able to see its machine code, how it's actually calling each instruction. Now, many of these things are just things you need to know. I don't need you to fully like master them. You need to just understand them a little so that you're able to then help as you continue. And then the more you learn to code, the more you will intuitively start to know these things. So being an introduction to the hardware, and I think what we'll do is when we finish with every course would have the material shared on our page on tech support, so that you can be able to follow. On the material we'll share, we'll put links so that you can do extensive reading on particular areas if you're interested. When we get to now programming, when we get to now introduction into programming, just a second. We are looking at introduction into programming now. I need to explain why I'm choosing one of the core beliefs that I have, I think, shared with very many people is that you don't need to learn all the languages that exist out there. You need to learn just maybe one language very well, and then any other language that you'd want to learn later, you'd be able to intuitively be able to learn, because you'll have the logic, it will just be an issue of semantics. As far as programming languages are concerned, I'd put it in three groups, largely, where you have procedural languages, and then you'd have one of the main procedural languages that has been there for a long while would be like I'd call Visual Basics. Everything you want to execute would be one functional block, then it would finish. So if you are writing a program, you'd see it as a sequence of executable instructions which are very written down. So it's like you're writing a list of rules. You'd go from one page to the next page. Object-oriented programming views things as objects, and an object would be like if you're creating an army, you'd view every soldier as a sort of an object when you classify a soldier. So if you look at what the soldier needs to do, there'd be like one standard object. So if you want many soldiers, then you can be able to then use the same kind of script to multiply the effect. The last one would be the functional programming, which is like a Lisp. Mainly in this one, Lisp, most of the programming would be used more for issues like when you're talking about artificial intelligence and a lot of data learning. For this class, we'll just focus on Java. On Java, I'll try and show you from how try and explain both the procedural and object-oriented programming. Now, going more towards Java, why I'm specifically picking Java for this class. Java is an object-oriented language. Being object-oriented, it means everything in Java is represented in a class. So everything will be a class. Yes. So everything will be a class. And then being a class, you find we'll be able to explain how a class works. Then the next thing that we need to be able to show you on Java, among the biggest things I like with Java is you can be able to write a desktop application. You can be able to write a web application. You use Java to write the mobile apps. So Java is extremely versatile in terms of what you can actually do with it. You can really use it to do almost every single thing you want to code. You can run Java on almost any kind of platform you want to run it on. It's platform independent, so you can code in Linux, in C, in Macintosh. So the robustness is what has encouraged me, because we are able to write one piece of code that can then run on Windows, on Linux, on we can be able to do web applications with it. So we found it very robust. Also, we've had quite a bit since it's been there for a while. It's really gotten mileage. So we've gotten quite a bit of people to use it. It's well documented. It has tutorials, and also it's free and open source. When I started to code with VB and Delphi in the 2000s, most of the development platforms were extremely expensive to buy the licensing. So these things are what encouraged me to use Java. Now, to explain a bit of what I mean with the platform independence, if you compile a program in like C, that program produces machine code that would run straight on the processor when called. So what Java people did when it was still with Sun System is they created what they call a virtual machine. The virtual machine created a harmonious platform that would run Java code in any environment. Then all they had to do is ensure the Java code, which is the main executable binaries, are there for Windows platform, any Linux variant, any Apple OS, or any other OS that they envisage. That way, they are able to isolate the developer from dealing with the low-end items. I'd also put a small disclaimer that if you then want to do very hardware-intensive coding, then Java may not work for you, because if you want to really start to call memory directly, you want to call a particular processor address spaces, then Java may not work for you. You have to go for C and C++. Now, I'll highlight this very quickly, because then on this lesson, which is just around half an hour, we want to also do some hands-on practical coding. I want to show you 2-3 things. On the basic introduction, I'd introduce 4 items. The first one is just variables. Variables is to be able to do any computation, the computer needs to store data. So in coding, you need to be able to know how to name that data so that you're able to then have what would call an object that you keep that data in. If you do low end coding with like C, that data is kept in memory, so you'd have to know which memory place you put it on. In most of the other languages, that apart from assembly, then you'd have to then have these in proper, you'd address it as a variable name. So it means anything you would want, you'd call it a name. I'll show you that practically. The second one would be how you'd encode a basic function. When you separate something, you want to say this function works from this place to this place. The third item would be operators. That means basic addition, basic subtractions. And on that, my son has been discovered that you can be able to ask this thing called Alexa mathematics. So you can ask it, Alexa, what is 1 plus 1? Then it says 2. What that means, he doesn't need to do so many sums. So on coding, you can be able to get the coding to be able to do all those operators. So the basic ones would be addition, subtraction, multiplications, and such. The last one for Java, it's something called a class, and that's what when I start the coding, I'll show you based on. That will be the presentation for now. We'll go to the I want to show you first how I'm a Linux person, so I think I'm logging into my Linux machine so that I can show you some instructions. I'm not very sure. I'm not able to regulate the font, but we'll be able to explain the instruction. The first thing I want to do is show you how machine code. In Linux, if you do a command obj dump /d, I want to take something like a program like copying a file, which is a command like cp. If I do this, I disassemble the program, then I'm able to see every line of code disassembled in assembly code, and then I'm able to see what that assembly code does. So things like pop is to pop a register. So like if I highlight, I can look at some of these, it just doesn't have a move. Like this would be, you're jumping to a given particular point of code, then you're moving a value from a register RSI to RDI. Then so this assembly code is what every single instruction, it does not matter whether you code in Java, whether you're writing code in PHP. At the end of the day, if it's a PHP program which has to then decompose whatever it is you're telling, the system has to instruct the processor in assembly machine code. And this is how it looks like. In the next lesson, I will try and get how to do this in Windows. I could do this in DOS, but I've been working on Linux a bit, so I've forgotten. So you can be able to disassemble any code. Anytime I used to do this long ago when you want to do reverse engineering. If you want to figure out how some program is running, you can easily be able to do this, and you can be able to see some of the code, and then you can be able, like for guys who write viruses and they need the virus to hook onto a part of code. Part of code has a lot of redundancy. There's code which is there that no one, is actively using. You have a piece of code which just has, I can try to, I can do a cut instruction to just do the dump. Most likely it will hang. If you see, there are some things which are just words that you can be able to look at the code and be able to figure out what you need to insert as code, which is a bit dangerous. But that is possible to do. So on this, I needed to show you how the machine code works. In the blogs that we'll do, we'll be able to get a screenshot, which is much better, that you can be able to follow for that. Now, I want to show you, we did a video on how to get started in Java, how to install the Java code. So I'm using NetBeans. Ordinarily, I code on I don't need an IDE to code. I code on bare projects, but I'll do a very simple program. So I just want to get a free class. And I'll just call this lesson 01A. So would have lesson 01A as one of the code we'll give. So I've created a class, and this is the first thing I need to explain is what it is. So if you see my code, I can even remove all the comments. If you do the /* up to this other star, all these are comments just to comment the code. This is the smallest Java code that you can ever write, which is a fully functional code. You can be able to compile this. So every single Java code you write must be contained within something called a class. You can even remove the public. Public means it's accessible by other classes, which you continue to learn. But if you just write class, lesson 1A, the name you write here has to be the same as the name of the file. Then you do open brace to close brace. The braces are used to indicate a function. So anything within any code fragment, any lines of code within Java must exist within an open brace and a closing brace. That's what defines a function. So the smallest, so all you need, every single thing is a class. We'll initially start to learn with one class, how one class works, of which we want to define basic variables. But what we want to do is just be able to define a class. So that's the most basic of Java code. Now, once you're able to do a class, like this class, you cannot be able to run the class. Like it's saying, there is no main to run. So the next thing we want to do with this class is to be able to create the running class. And that is done by writing so you write public static void, and on this point you have to believe me like religion. Later as you continue string as you continue learning and understanding, you'll understand what this does. But to put it simply, Java needs to know where to start running from when it's being run as a function on command. So this, for it to run like that, it looks for a program, a function called main. So we've written our first function. So we've written our first class. Now we've written our first function. So the first function must be called main. So when you have a main class, that's the time then you are able to get uh, you're able to get it to run. So if you just write public class lesson 1A, the main class, now what I need to do is just show you the basic, to ensure you can write something. There's something they always call hello world. It's used as a joke. But what we'll do is we'll declare a variable, we'll add up those variables. So we'll do string. When you define string, that's a variable. So if I define string, so I had to call it h1 as a name, and I say hello, then every single line of Java ends with a semicolon. So if I write string h2, so I've created two variables. The first variable is h1 and h2, and then I want to create to call a command system. And then what I want to do is I want to do h1 plus h2. Now, when I started coding, when you click run, the number of errors you'd get would be in the region of 100 plus. It's telling you you've written too many errors. That's enough. Stop coding. And don't worry about the errors. The main thing with coding is keeping on learning. And I learn every day. Even as I do the lessons and train, that will be a lot of learning. So with this first program, I've been able to show you how to do a class, how to do a function, how to create a variable. I have put in one operator, which is the addition, and then I'm able to see some output. So if I run the program, I'm able to see hello world at the bottom. This will be our lesson for today, which was to introduce you to Java at the very basics of Java. We will edit this into a blog so that you can be able to refer, and the people who join our lessons later can be able to pick up on our lessons. Subscribe to our channel so that you can be able to get alerts. For the next other 3 lessons, we'll have them on Wednesday at 2:30, every 2:30. Thank you very much for attending this lesson.